Hello, everybody. My name is Francisco Martin, and I'm the co-founder and the CEO of BIGML. My strong accent is because I'm originally from Spain. I'm going to start telling you a little bit about myself. All right. I hold a 5-year degree in computer science, PhD on artificial intelligence. I already developed a system that learned to reduce the number of alerts that intrusion detection generates many years ago, more than 15 years ago. And I also researched on machine learning during my postdoc at Oregon State University back in 2003 and 2004. I have created 3 AI-powered companies. The first one in 1999, the second one in 2004, and the third one in 2011. The 3 of them are live and kicking. And I can say that I spent the first 15 years of my career developing intelligent systems using machine learning tools that were developed by others. And I have spent the last 6 years developing a machine learning platform so that others can build intelligent applications. BIGML, my current company, has now more than 45,000 users in around 120 countries that have been performing over the last 6 years more than 70 million tasks. All right, I think it's more like 8 million tasks during the last year. And you need to take in account that each of those tasks can be either a very simple machine learning task, as training a decision tree, or it can also be a very complex workflow, like finding the best parameters for a random decision forest. That in turn requires to run thousands of tasks. All right. So I can say that the total number of individual models that BIGML has been creating is in the hundreds of millions. All right. And the mission of BIGML is making machine learning beautifully simple for everyone. Actually, we were one of the first companies trying to democratize machine learning. Lately, there have been a lot of discussion about what democratizing machine learning really means, right? If you take the example of Google's TENSORFLOW, they open sourced it, I don't remember exactly, but almost 2 years ago now, and it has more than 26,000 forks, all right? Not too bad after a great and a huge company promoting it worldwide. But if you look at the number of people contributing, there are like 700 committers, all right? And if you check, or at least the last time I checked it, the number of people that have been making more than 10 commits, all right, I think it's less than 100, all right? So the proportion of people who really get how TensorFlow really works under the scenes is very, very small, right? So I can say that there are like 2 ways to think about democratizing machine learning, all right? On one way, building an affordable machine learning platform that is accessible via an API or a point-and-click interface that abstracts away all the complexities regarding algorithms and infrastructure, all right? And the other way to think about democratizing machine learning is open sourcing a complex framework, all right, that only a few people can install, configure, and run. And the number of people, as I mentioned before, that can update the software is relatively small, all right, very, very small. And in order to use it, you need a very costly infrastructure, all right? But today, I think I'm going to talk not about what really democratizing machine learning means, but just the fact that there are many more tools that are accessible to many more people, right, to solve end-to-end applications with machine learning, all right? I think it's going to be increasing the number of people that are going to be discovering the real-world barriers that you need to confront. Want to apply one of the machine learning algorithms that these tools make really accessible. All right. So let me now explain what I understand by end-to-end machine learning. All right. So most times when you hear to talk about machine learning, most people exclusively focus in one part of the machine learning cycle. All right. That is the algorithm that allows you to build a model from data, all right? And there's a lot of research, you know, the community has been working on this for more than 36 years, all right? And there's many ways to build a model, many ways to evaluate a model, all right? And this happens in most of the textbooks and online classes, you know, you always get taught about the same things, all right? A bunch of algorithms that they can work on different types of data, and they can help you solve a machine learning problem, all right? And this is normal because this is the core of machine learning. However, to develop a machine learning application, you need to consider a few more tasks, all right? And often, these tasks are even more important than the own machine learning algorithm themselves, all right? And there is always a misconception of why you need to work on these tasks, but they are crucial, all right, to bring machine learning to the real world, all right? One of the most important is, of course, collecting and structuring the data, all right? Feature engineering for traditional machine learning, this is the key, all right? At the same level as now to really use the learning in the real world, you need to have a lot of experience with network engineering, all right, to define the structure of the network that you want to train, all right? So once the model is learned and optimized, all right, you need to find ways to bring this model to production and to make available to start making predictions for new data points, and finally, you need to find a way to measure the impact, all right? And this is a very iterative process, right? You need to go back and collect more data, prepare the new data, see if the feature engineering or the network engineering you're doing is right, learning, deploying again, and making more predictions, and so on and so forth, all right? So one of my key points today is that many of these tasks that help you go from raw data to predictions, all right, are still black art, you know? There's only a few folks that probably know how to implement this in the right way, you know? And it's very hard to find in the textbooks, right? And only the part of learning the models have been well researched, right? However, to bring a machine learning to the real world, you need the rest too, right? So what I mean by real world applications, right, are end-to-end machine learning in domains that are dynamic, that are imprecise, and often also adversarial, all right? So in order to call a machine learning application real world, all right, I like to say that needs to be end-to-end, you know? You need to have a fully automated workflow that reduce a maximum the human intervention, all right, from going to data to predictions, all right? Each prediction that the system makes needs to have an impact on business operations, you know, or on financial well-being, all right? It's like you need to be conscious about the cost of making the right or the wrong predictions, right? And this application needs to operate in a setting, in a scenario, all right, where that is dynamic and it changes over time, all right, and where things are not perfectly defined, all right, and where you can confront some adversarial condition. And let me tell you that some people believe that they are machine learning experts because they are doing very good at Kaggle competitions, but Kaggle is not real-world machine learning, all right? You just get a very well-defined training set, all right? You even get a peak of the test set, an evaluation procedure that gives you a metric of how you might end up in the leaderboard of the competition, you know? Most of the evaluations are cost insensitive, you know, and the final test set doesn't change over time. And so I think that there are many things that, okay, it's a great tool to learn more about how to optimize a machine learning model, but it's not the right tool to know how to work with machine learning in the real world. All right. So today I'm going to give you 4 takeaways. All right. The first one is there's too much hype and too high expectations generated by people who have never developed an intelligent system for the real world, all right? And this is leading to another AI winter, all right? The second one is all this hype is mainly originated by a number of small victories of machine learning techniques that most times they have more than a decade, you know, they are significantly old, right? And they work now thanks to have faster and cheaper computers, right? The third takeaway is that real-world machine learning is still unexplored. I have mentioned this already a few times today. And machine learning engineering, what can help us to bring or build more machine learning applications, the knowledge of the experience that has been collected by advanced practitioners is not out there for newcomers, right? And this forces the newcomers to make the same mistakes again and again, all right? So I'm gonna start now explaining why an AI winter is coming. I really believe that this is gonna happen, and why, you know, I think that many people believe that the party is just starting. There is a lot of money going to many different projects, many different startups, you know. Only last year, more than 1.6 billion invested in AI companies, you know. The number of acquisitions of AI companies is skyrocketing. You know, why this winter is going to be coming soon? I think that there are many unrealistic expectations, all right? And all these expectations will be very soon turned into an excess of negativism against artificial intelligence, as already happened a few times in the past, right? So many of these projects are now over-promising at the risk of under-delivering, all right? And I think that time will say, but probably we are going to see a few things or a few approaches failing very soon, all right? And if you look at the number of public companies mentioning AI over the last few quarters, this is increasing exponentially, all right? And but many of these companies, turns out that they don't have that much experience on AI, all right? And they have never tested any real-world machine learning application, all right? So there are going to be many of those facing at the same time the same problems and so on, right? So one of the main reasons why I believe that the AI winter is coming soon is what I call the AI amplification, all right? That is created by media and often self-promotion, all right? Someone published a paper on a little application on machine learning, and all of a sudden, the media exaggerates its content and implications, all right? If you take, for example, this is a paper from a few radiologists, you know, excellent paper. There is an application of machine learning that analyzes three-dimensional cardiac motion and the result of an application developed on top of R managed to reduce or to increase the area under the cure, all right? And they're using data from 256 people, and the area under the cure is like 0.72 or something like that, all right? So it's like a small experiment. I don't know how you can extrapolate this to all the people in the world, just taking 256 a sample, so small. But anyways, nice article. But when the media talks about this article, says artificial intelligence predict when heart will fail, all right? So this level of exaggeration, you know, this sensationalism is not helping a lot to get some rational in the way we want to bring these tools to market, all right? So this is another example where things go even in a more exaggerated way, you know, where they give you the impression that a Google DeepMind algorithm is capable of going and by itself learning to play Atari games, you know, never mention the number of people behind the scenes working super hard, preparing the data, programming the algorithms, testing the algorithms, and making sure that everything works, all right? So anyway, my point here is that AI is a late project, all right? We already generated many expectations more than 50 years ago, and the human beings, we were incapable of bringing these high expectations to reality, all right? And the same thing is going to happen now, you know, and it's very well known in software engineering that when you add more resources to a late project, this project is going to be turning to be later, all right? So I think that we're going to see this, all these hundreds of thousands of people at the same time solving the same problems. It's not going to be good, all right? So if you don't believe me, I think that, and you check the news, there are already some setbacks, all right? A few months ago, one of the centers that are investigating on cancer was just shooting down a project where they have already invested more than $60 million, right? If you look at the way the Facebook bots are playing, you know, I think that they discovered that NLP in the real world is more complicated than it looks, right? This is like basically like President Donald Trump discovering that healthcare is complicated, all right? So and the level is reaching to a point where artificial intelligence is becoming meaningless, all right? Because all software, even if it's using some hard-coded rules, is now called AI, all right? So how to kill this hype, all right? I think that we need more reproducible AI research, all right? We need more educated media, all right? I can't believe that in 2017, most journalists cannot tell apart machine learning from AI, all right? And then the public also needs to be more educated and calling off the media, all right? And I think that in general, more people will be seeing what is the real impact, the real benefits of bringing AI in general to the industry or to solve real world problems, all right? But I think that we need to have clear that most of the hype generated has been originated by a few machine learning techniques that were very good, all right? And I'm going to try to explain now why this is happening now, right? So from all the AI disciplines, knowledge representation, planning, reasoning, all right? Machine learning has been the discipline with more or with higher reproducibility, all right? The community very early on creating a number of data sets, and people were using these data sets to compare the results, you know, and I think that this has been very helpful. I don't know if in planning, in reasoning, you know, if the communities, they develop something similar, all right? So why now? I think that one of the most important factors is because computers are faster than ever, all right? And this is a slide from Shane Lang, one of the co-founders of DeepMind, all right? So you take a computer system and you try to train it in the 90s, it had been taking 250 years, you know, something that now you can train in a couple of hours, right? As you know, machine learning is very iterative, all right? Just experimenting or discovering that you got the wrong network structure or the wrong parameters in the 90s will be very, very, very costly, all right? And now it's something that you can run a few experiments every day, all right? So in addition to the speed of computation, all right, the cost of computation, machines are cheaper. The machine learning techniques are more mature. There are people that believe that the learning is new, and the learning, the first reference in the bibliography goes back to 1986, all right? And there's more data because the digitization, you know, that started in the 90s. And there are more tools, you know, like BIGML or TensorFlow or many other companies or APIs that allow you to do machine learning very easy now, all right? So to bring machine learning to the real world is still unexplored, all right? More machine learning engineering is needed, all right? And but most of this is still a black art, all right? So let me give you now a rough comparison of the amount of research that the whole world has been devoted to what I call pre-production machine learning, all right? There's a lot. You can, there's many journals, conferences, many things that are about training models, right, in a setup that is at the lab level, you know, but nobody tells about, well, okay, this model was running in production for this many months, this many years, you know, in this kind of setting, and this was the whole process to get this in production, and it worked or it didn't work, you know. The research community always tend to publish things that work, but they don't tell you anything about things that don't work, all right? So many people need to learn the same lessons again and again, all right? The level of research about production ML is very low, all right? Only recently, the last few years, you can see conferences or where there are certain workshops that talk about this, all right? And into the wild machine learning, where you just code a system that can automatically learn, generate models, make predictions, and retrain the model, you know, there's only few places where this has been discussed, all right? So I think that we are right at the beginning of generating more knowledge and more experience in a worldwide basis, you know, to know how to run machine learning into the real world, right? So I see like three generations of machine learning, all right? Of machine learning practitioners. Those folks that were learning machine learning in a traditional way, you know, with the UCI repository or ImageNet, you know, different well-known repositories of data sets that were very helpful for people to know the applicability and certain theoretical properties of algorithms, you know, over a number of years. Kaggle, I think that it made a great impact in the world, you know, allowing many people to share new tricks to being able to optimize a model for a particular test set, all right? But if you look at to the best of my knowledge, nobody ever invented a new algorithm, significantly fundamental new algorithm, thanks to the Kaggle competitions. You know, I think that there were many people combining different approaches, configuring things differently, and applying tons of black art, tons of tricks, right, to win the competition. So I believe that a new framework, all right, where people can test real world applications is going to be needed, all right? I don't know who will be creating this on web, all right? But without that, you know, it's going to be very difficult to have research in a worldwide basis, you know, where people can compare the results. I think that DARPA has been doing an excellent job over the years, you know, creating challenges, you know, where people are submitting the application and getting the results back, you know, more in this direction, all right? So let me finally share some thoughts on machine learning engineering, all right? I'm telling you that this is still at a very, very early stage, all right? And I think that if you were into software engineering in the 90s and you start becoming proficient in the development of software and you wanted to become a software architect, you quickly ran into this book by Eric Gamma, all right, that was talking about reusable design patterns, all right? So a similar book doesn't exist yet for machine learning, all right? Most of the textbooks just focus on the modeling part and not on the full end-to-end machine learning workflow, all right? I think that the closest thing I ever found is a paper that was published by Martin Sienkiewicz in the context of a workshop in the last NIPS in Barcelona at the end of last year, all right? But there's not too much literature explaining you how to bring this or reuse these patterns to bring machine learning to the real world, all right? So let me now describe what are the key tasks of machine learning engineering, all right? Obviously, learning and evaluations, that is very important, but then there's many other tasks, that need to be performed, all right? From data engineering, how to collect the data, how to perform feature engineering. Learning and evaluating is part of what I call workflow engineering, all right? You need to know exactly what the workflows that you want to apply. I go a little bit more in detail later, all right? And then you need to deploy this model, find a way where you can automatically put these models into production. And then there's, I'll explain a little bit more later, machine learning debugging is very complicated. And also you need to be concerned with security in many different settings, all right? So I'm gonna just very briefly tell you about data engineering. I think that probably you already know that in order to apply machine learning, you need to prepare the data and in a way where sometimes it looks very trivial. You just put the data in tabular format where every row represents an instance and every column represents an attribute or a type. But what happens in the real world is that most data are collected and stored with a machine learning in mind, right? You have data that is often stored in relational models, all right? And you need to denormalize this data in order to be able to use it for a machine learning application, right? Over the last few years, many people have been designing data lakes, but they didn't have machine learning in mind. And as soon as they want to do a machine learning application, they discover that they need to redo many of the ETLs that they were preparing for these data lakes, all right? So it requires experience. And transforming this data for machine learning is sometimes painful and it's very error prone, there's a lot of manual intervention. And on the other hand, designing applications that learn from scratch, is still an explore, I think that there are many people trying to apply machine learning to data that has been already generated by an information system before, but only a few people that are developing new applications that they are considering machine learning at the core of the application, right? I think in the future we'll see many more of these applications. And I think last point here is that it's not fun when you tell your man that you were hired as a data scientist just to call a few months later and telling that you're spending 90% of your time cleaning data, right? That is what happens in many machine learning projects, right? So this is a picture of a real world application that is processing data from different data sources, Crunchbase, the Patent Office, the Wayback Machine, Twitter, and structuring a data set. As you see, the workflows that you need to implement in order to transfer this data is not trivial, and you can make many mistakes, all right, that are going to have a significant impact in the quality of the models that you're going to be learning, right? So the other fundamental part on data engineering is, in the case of traditional machine learning, is feature engineering, right? The very first book on feature engineering is going to be published on June 25. There's no books. You cannot go and buy a book and that teach you how to do this, So hopefully over the next few years, there were more books, there were more classes. This will become, as more people are developing real-world applications, they will become part of the textbooks, of the classes that you can take online to learn about machine learning, right? So in terms of workflow engineering, just taking the example of the Kaggle competitions, where you are already giving a prepared data set, all right? Sometimes you need to do some feature engineering, but you're never concerned with the compositionality that solving a machine learning problem in the real world requires, right? So usually these problems need a combination of algorithms, right? I'm not talking only about, okay, seeing if a logistic regression is better than a random decision forest, I'm talking about you need to take the data set, you need to remove some anomalies, you need to now cluster the data set because probably it's better to build 4 or 5 different models, for one for every cluster. All these workflow, if you want to apply this automatically, they need to be very well defined. And it's a combination of different algorithms, all right? And the output of an algorithm becomes the input of another algorithm, all right? And there is also at a higher level a way to look at these workflows where the task is not ending when the algorithm is evaluated and you get the top performer algorithm according to certain metrics. It finishes when this model is running in production, and you need to be concerned also with the efficiency of the model working in production. You need to catch the model. You need to make sure that you need real-time predictions, how you're going to be generating millions of predictions per second. You need that, right? So, and the last few years, I think that we are in the real world, we are seeing there's a change of trend of the old thoughts of having a model for everyone. Imagine a bank taking 2 years to create a model for granting mortgages, versus Google that is capable of generating millions of models, one for every customer, for every priority inbox in Gmail, So it's all the workflow thing. It's very, very important. I think that most of the research, most people are just focusing on individual model for a very specific task when it's much more complicated in the real world. What we see, this is a pipeline from Airbnb, something that they published a couple of years ago. It's very weak. There is so many manual interventions. You create the model in one tool, you explore that to another tool, you use another tool to run the models in production. There are so many steps where a human being can make a mistake, that it doesn't matter how good your algorithm or machine learning algorithm is, if there are other parts where you can fail, the whole thing probably is going to be failing there, right? Debugging machine learning. There's an excellent blog post from sensationalist, a student at Stanford, where he explains very nicely how complicated is debugging machine learning. All right, when you debug traditional software, you have only 2 concerns. All right, the algorithm and the implementation of the algorithm. When you debug machine learning, there are many other things that you need to consider. All right, all the parameters of the machine learning algorithm, the learning rate, if it's overfitting or not, the regularization that you're using, and additionally, everything that is related to the data, and using the appropriate levels, and using a data set that reflects exactly the data I'm going to find in production. There are many other things that you need to consider. In terms of security, I think that very, very recently, Wired Magazine was talking about an article from a few researchers at Cornell University, a few security researchers. They were rediscovering that once you have a machine learning model in production, someone can send some inputs and can get some labels back, and you can use these inputs and these labels to regenerate a copy of the model, all right? This for people that have been doing machine learning for a while, this is very well known, all right? But it looks like they were surprised that you can really make a copy of a model, all right? So if you're running machine learning in production, depending on how mission critical your application is, you need to be considering some anti-robbery techniques, to avoid situations like this, all right? And I think Many people have seen this picture before, you know, where someone takes a dog, the picture of a dog, adds a nose, you know, and suddenly a neural network can classify this dog as an oxley, all right? And this is for fun, but you start thinking of applications where adding some noise to a stop sign can be transformed into a yield sign. This is start being more dangerous, all right? And many people say, okay, no, you can only do this if you have access to the model, all right? But as I mentioned before, models can be still, all right? So you need to be overall concerned with the security of your application, all right? So finally, the takeaways, all right? I think that too much hype and too high expectations are leading to another AI winter. Machine learning techniques were invented many years ago, all right? Generally speaking, I don't think that nothing completely new, fundamentally new has been invented in the last 10 years. Everything that we are seeing now is because computers are faster and cheaper, all right? And there's a lot of exploration to do in terms of bringing or building machine learning applications for the real world, you know? And I hope that over the next few years, you know, the universities and the academies, they start bringing more books, more knowledge, you know, serve in a worldwide basis about how to really build machine learning applications that are ready to impact in the real world. All right. So I'm gonna finish here now. So now I'm supposed to answer the questions here. Let me go to the beginning. Another AI winter, no, but with all the high, not surprising. I mean, where is my hoverboard? When investors will realize that everything has been explored by current AI techniques, then the AI winter will come, I think. I think that's something curious that is happening now with investors is that they invested all this money in many startups over the last few years, but they weren't using any AI or machine learning application in order to make these decisions, you know? So very, very interesting. And where people can actually advance with their projects in peace. I think that research takes time, you know? It took many, many years of the most brilliant people in Earth in order to invent very good algorithms for machine learning. I don't think that this can be done in a daily basis, you know, when a super great machine learning researcher is hired by Apple or by Facebook, you know, I don't think that the millions of dollars that they get paid, you know, amplify their brain, you know. They're not going to be immediately inventing something new, you know, in a matter of weeks or a matter of months, you know, probably over the years that if they're in touch with real world data, you know, trying to solve problems, they can invent something, but it's not, they're not going to be generating any impact in the anytime soon, you know. So do you think that we are overly optimistic about the rise of AI and what it could achieve within 25 years as experts and especially economists? I think that we are going to continue seeing a small number of victories. All right, we're going to be seeing certain people doing great things for very specific things. All right, and I hope that in general, the AI community, the rest of things that are really needed in order to make an intelligent system, like planning, like reasoning, like knowledge representation, learns the lessons of what is going on now just with the specific area of machine learning, so that everything can be at the same level and it can become easier for many people to build a more general AI applications, all right? Do you think that the feature of machine learning models is continued application of more advanced statistical methods and better algorithms, or more biologically inspired self-learning tactics? Numenta, I do believe that everything that we use in the community, when we use neural networks, right, and I think it's a great way to attract the attention of journalists, right? I think that overall, the people that study medicine, you know, what we know about the brain is so low. I think that we don't know absolutely anything, you know, just roughly exploring now how it works, you know. So trying to say that a machine is copying the way the brain works, you know, I think, again, it's great to attract the media, but I don't think that we are very, very far away of knowing how the brains work, and maybe later we can start applying this to some software. I think it's better to focus on the way software architectures, you know, and hardware architectures work, you know, and trying to use that. If you take the simple example of the way we can compute a decision tree, right, and learning something very quickly, you know, practically in any domain, you know, our brain doesn't think that way, you know, but it's an efficient way to use the machine. So I think that is the way this is going to be working, right? Does BIGML do any machine learning AutoML? In other words, autonomously testing multiple machine learning algorithms? Yes, we have an implementation of a Smackdown, and that can find automatically all the best parameters for an ensemble, you know, or any of the algorithms that BIGML uses, you know. But again, finding the best parameters is only one part of the whole workflow that you need to implement, you know. We don't have nothing, and to the best of my knowledge, there are some people that are researching on this at very early stage, but there's nothing that goes back to the data, you know, and start finding what can be the best combination of features, you know, or what are the new features that I can generate. We still need a lot of human expert knowledge, you know, both in terms of knowing what are the combination of features or knowing very well the application domain, you know, because feature engineering actually is a way to transfer some domain knowledge, you know, so that the machine learning algorithm can do much better, you know. In the learning, you know, part of this work is done by the own architecture, you know, all the combinations of different features that can be used, you know, but it makes harder to use domain knowledge in order to train a deep learning system, all right? So inserting my email, if someone has more questions or needs the presentation or whatever, please send me an email, and I'm happy to answer offline. All right. Thank you very much, everyone. Bye now.